So this is going to be going through the execution for the SOS challenges study. So this session is going to be myself and Jack giving the demo, but at 7 p.m. later, if you're very excited about this and you want to rewatch it, Senna and Chungsu will be doing the demo at that time. So just to give you a bit of an overview of where we have been and where we're going, the study started with the research question, and then there was the week where there was the data diagnostics to see for the research question what data sets had the components that could be used for that research question, and the databases either passed, which meant they could continue, or they failed. Then if they passed, we then did the phenotyping to see the cohort definitions. And again, we looked at the diagnostics on the databases that passed to see which databases were suitable or not, and whether to stop the study or continue. And then we got to the analysis design. And last week, Patrick went through the analysis design choices of how you can actually pick the different choices for the characterization, the prediction, and the estimation studies. And at the end of last week, he created that JSON specification. And what we're going to start from this week is we're going to take that JSON specification that said what we wanted to do and how we wanted to do it, and we're going to plug that into this package known as Strategus. And that's now going to run the study for us on our OHDSI database. And it will then generate the results in the study diagnostics. And then next week, we'll be going through the results to actually see whether the database is passed for the different analyses and actually do the unblinding and the reveal of the results. So this part is actually running the study that was designed based on all the previous work that we've been doing over the last few weeks. So Strategus is the pipeline that we use for execution. It's very simple. It's the new strategy that we've came up with. So previously, if you ran network studies, we used to create packages. So we had this skeleton package, and we'd create a package for a characterization study, and we'd create a package for a prediction study, and we'd create a package for a population level effect estimation study. So if you wanted to do everything, you would have lots of different packages. And within each of these packages, they had different ways of doing the cohort generation and different ways of actually doing some of the processes. Now, Strategus gets rid of all this. Instead of having all these different packages, you now got one execution. You've created that one JSON. It's going to be used by that execution and Strategus to generate your results for characterization and or prediction and or population estimation. And you could even plug in other modules. So it's this very nice modular approach, and it standardizes everything. So the characterization, the population level estimate, prediction, and population level effect estimation, and the patient prediction are all going to use the same process to generate the cohorts, and they're all going to output CSV results. So we've actually standardized everything even more with the Strategus pipeline. So before I actually dive in and give you a demo and show you how simple it is, I'm just going to give you a little bit of a background about what Strategus is. So Strategus is our new approach for network studies. I already mentioned that it standardizes everything, and it takes as input this JSON. So previously, Patrick created this JSON for the model spec. That is basically going to be the input into Strategus. And then Strategus is going to see that JSON. It's going to know what analyses you want to run and what settings you want to plug into it. It's a modular approach. So you see this figure here of this Lego car. Effectively, the modules like the patient of prediction module and the cohort method module and the characterization module, these are Lego bricks, and Strategus is building that into a car or into a network study. So it's a modular approach, which is nice. And the third thing, which is probably actually one of the key parts really of the Strategus, is it handles the R environment. So for those of you who did network studies over the last few years, if you look at the studies that we ran, say 5 years ago, and you try and run one of those packages now, I would guarantee almost that package is not going to run unless someone's updated it. So a package that was generated years ago will be very unlikely to run now. And this is kind of like a bad thing, because we want our studies to be reproducible. If you can't rerun the package from 5 years ago, it's not reproducible. And the reason for that is that the dependencies, so for all of our OHDSI packages, they have R dependencies. They use other R packages. We use things like the tidy universe a lot. And for example, one package is dplyr. If dplyr changes over time and the inputs to it change, it will break if we're calling it from a new version of our packages. And so all of these dependencies cause this issue where things can break in R over time. And this is what causes our packages to not work. So try running an old network study, and you're probably going to fail. And our solution to this was this R environment and configuration using RM. So basically, you save all the packages and the versions of the package in a file. And then when Strategus runs, it configures that. So it has the packages that you need and the versions, and they're fixed. And this is what wasn't happening with the old packages. So Strategus should solve this issue and make it so that we're more likely to be able to run a study 5 years down the line. Whereas before, when we were having packages, we weren't able to do that. So the R environment configuration is a key part of Strategus that's making it so that it's reproducible. The reality is Strategus is still in development. So I just want to kind of show like this is a new package that's being developed by Anthony Senna, and he's done a lot of work, and he's made it so simple to do the execution, but it's still in development. So there may be the odd thing that pops up that we have to kind of fix. So Strategus modules, we've got lots of different modules already being built. So we have modules for cohort generation that will create your cohorts. We have modules for various characterizations like incidence, cohort diagnostics, and characterization that will characterize the population of interest. We have modules for estimation, cohort methods, self-control case series, and evidence synthesis. And we have modules for patient health prediction. The nice thing with Strategus is you can add additional modules. So it's very easy for someone to actually create a new module that wraps around some form of analysis package. So if you wanted to do something other than estimation, patient prediction, or characterization in the future, you could create a module and then Strategus could run that. So it's making it very broad in the types of analyses that we can do. You may be asking what's inside a module, how is it different from a Hades package? Well, a module is basically an R project. So it has a RM inside it, which is what I was mentioning that we need to know what the environment of the R packages we need for things to run. And it has a method for basically creating the settings for the JSON. And this is actually what was being used by Patrick last week. He was actually using the module settings to make sure that you had this way of configuring the JSON spec that would be compliant with the module. And then it also has an execute function. So this execute function will take the settings for the module that's in the JSON specification and know how to basically run that around the Hades package. So for prediction, for example, it will have settings for a model design in the JSON that gets called into the module, and the module then knows how to plug that into the patient health prediction package to get the models that we want to be implemented. And then the output of a module is always CSV files. This is just so that it's very transparent what you're sharing. When we did packages 5 years ago, we didn't always output CSV files. Sometimes we would output things like RDS files that are not transparent. You can't open an RDS file and just look at what's in there. You have to go into R and you have to open it, and it's not very friendly and things could be hidden. So CSV files, a lot more friendly. You can just go open your CSV files, see what it is you're sharing, and actually look at the results as well. So this is a little bit of a thing that's changed over time from lessons learned from our packages. Another thing that I've kind of been mentioning is this ability to combine modules. So previously, when we created packages for studies, you'd have to have a package for cohort diagnostics and a package for prediction and a package for cohort method if you wanted to run all 3 of those studies. So someone would have to download and install 3 different packages for 3 different study packages, and then they would have to execute those, and then they would have to share 3 lots of results back to the study coordinator. The nice thing with Strategus is that it lets you combine them. So if you wanted to just do a characterization, that's fine. You could do a characterization by just saying characterization module and the cohort generator module. But if you wanted to do something like patient prediction and cohort incidence, You can do that with Strategis. You just put both of those into your specifications, and Strategis is going to run both of these type of analyses. Alternatively, you may want to do two types of prediction and a coincidence. Again, you can plug that, or what we're going to do today is we're just going to do everything that we have modules for. So the nice thing with Strategis is you can figure out what types of analyses you want, and you can build up those blocks, those modules, and any combination you want to do. And it's just one execution that will do all of this. And you're going to see how simple it is when I actually show you the demo. Now, there are a few prerequisites for Strategis. One, you need to have your data mapped to the OMOP CDM. So this is pretty much the standard for all of OHDSI studies. You need to have that standardized data. And then secondly, you do need to have some software set up. So you need to have R, you need to have RStudio, Java, and then there is a setting called a GitHub personal access token that is very useful to set up. So all of these instructions for getting the software are available at this link at odyssey.github.io/hades/rsetup.html. If you go there, you actually see all the instructions for getting everything ready. The GitHub personal access token, this isn't necessarily required, but what it does is it means you have an unlimited number of downloads from GitHub. If you don't have this set up, sometimes you can reach a maximum kind of download limit for the day and it won't let you download anymore. So that's the reason why we recommend that you have that set up. But that's in the instructions. So you can actually get everything set up. As long as you have your data, then you're ready to basically participate in this network study and run this execution. So I've been saying a lot about Strategis, and I've been saying about how simple it is. It's basically 5 steps in less than 15 minutes is what it should take you. So these are the 5 steps. If it's taking you more than 15 minutes, then there's probably something wrong. So we've got that meeting on the Friday. I believe Anthony Senna's leading the office hours on Friday morning at 9 a.m., I believe, from the earlier slide. So if you run into any issue that's taken more than 15 minutes, I do recommend going there. And he has done a great job of Strategis. He knows it really well, and he can normally help you debug it very, very quickly. So I recommend going there. But generally, if everything goes, it should be very, very quick for you to run. First thing you have to do is just download a project. And I'm going to show you how to do that. It's a very simple thing to do. Then you've got to configure. So there is actually a file that Anthony set up that will actually set everything up on your computer, which makes things very easy. And I'm going to show you again, that is basically about 10 to 20 lines of just putting in your settings. The execute, again, this is another script that Senna set up, which is super easy. It's just a few lines that you have to change. You enter that, and then it should just trigger a Strategis with the JSON spec that was created previous weeks and actually start executing. Then finally, you do have to do a little bit of work to yourself to review the CSV files, just to make sure you're happy with what you're sharing and there's nothing in those CSVs that you don't want to share. For example, you want to make sure that it's censoring the min cell count. And then the final thing is just sharing the script, which again, Anthony Senna's created a very easy script that you just change 2 lines, I believe, for the sharing, and it will actually zip up CSV files that you've reviewed, and then it will send that over to the coordinator of the project. So this is how you do a study. Now there are 4 different studies, I think, that we're running. So you would have to do this for each study that you're actually executing. For example, I'm going to show you the anti-VEGF study, but then there's the fluoroquinoline and a bunch of other studies. You're going to have basically one kind of JSON spec per study. So you're going to have to run this execution for each JSON spec. So the first thing is downloading the project. To download the project, you just have to go to the projects on the GitHub OHDSI Studies repo. So I'm going to be showing you the anti-VEGF kidney failure one. But again, it's the same process for each of these different SOS studies that we're doing. It's going to be the same process. You're going to go to the GitHub. It's going to be a different link, but it's going to be the same idea. You go there, you're going to basically go to the code button, which is green. Hopefully it's green for all the different operating systems. I know it's green for the Mac. You go there, you press the button, and then there's going to be an option to download the zip. You then download the zip. I'm using a Mac, so it doesn't actually make me unzip it. But if you're using Windows, you then have to unzip from your downloads folder and then open it. So I'm just going to show you actually how to do this live, because as I mentioned, it's pretty simple. So I can actually show you this very quickly. So I've already gone to this GitHub repository. I'm just going to zoom in just so that people can see. So I've gone into OHDSI studies, anti-VEGF kidney failure. And when you go in, you're going to see a bunch of files like this. And this is basically all the code you need to run the project. And you can see here, this is the actual project itself. This is a bunch of scripts that the Senna's created just to make it a very, very smooth process. There's an instant here folder. This is where we have the JSON spec that Patrick created last week. So this is our study specification. And then we also have the things like the protocols in here. So there isn't too much in here, but this is basically all you need. And what you would do is you go to this green button, which hopefully will be green for any operating system. It's definitely green on Mac. You go to this code button, and when you press on that, it's going to open up this option of basically cloning on GitHub or opening or downloading. The easiest approach is just to press this download zip. So if I press this, what's going to happen is it's now going to basically get downloaded. So it kind of went into my download folder. If I open up my Finder, I'm already in my downloads here. And you'll see that there's this new folder that I downloaded today at 11:25 a.m., which is matching my clock. So if I click here, it's going to have exactly the same files that we had here. So I've just basically downloaded this repo, and that's all I did. So that's the first step that you need to do. And then once you've done that, if you're on a Mac, you may have to unzip it. Luckily, with the Windows, if you're on the Windows, you may have to unzip it. But with the Mac, it's already unzipped it for me, so it's actually made it a bit more easy. And then if I go to the project, so you want to find this anti-VEGF kidney failure.r project file. And if you double click on this, it's going to open up your project in an RStudio, as long as you have the RStudio installed. So if I double click this, it now opens up, and I've got this open. So I like to see here the files I've got. So you can see exactly the same files that we had on the GitHub repo, exactly the same files that we downloaded, are now here viewable in the RStudio. Now I've made some slight edits, so I'm going to actually be opening a version that I've had filled out some of the entries already in here. So you're going to see me actually using a slightly different RStudio, but it's the same thing. It's got the files that I downloaded from the repo. So if I go back to the presentation, I basically just follow these processes, and you can see it shouldn't take more than a minute or so to do this download and open up the project, as long as you have the RStudio and everything set up. So the next thing that you need to do is the config. So in this, once you've opened up your R project, you're going to see the bunch of files on the side, like I showed you. And then the file that you want to open is this keyring setup. So Senna has made these files so it's very, very nice and friendly. So once you open that up, you're going to basically see something like this pop up. Well, you're going to see exactly this pop up, actually. And the first thing that you need to do is install the keyring. So keyring is an R package that lets you save your sensitive stuff in an encrypted way. So I use keyring for saving my usernames and my passwords and my database server. And we use keyring for Strategus just to make sure that things are safe and encrypted, and we're not saving passwords in some files on our computer that people could easily access. So you do need to have keyring installed. That is something that Strategus is using. And because of that, Anthony created this keyring setup where he's also setting up some connection settings for you using keyring. So what you do is you would install keyring. And then this next part here is checking to see if you have an environmental variable set for your keyring password, because he's going to use that in the code later on. So here, this is basically just going to check that. This is a nice little script that Senna added to basically just make sure that things were set up. So I'm going to show you what happens when you run that. But effectively, on my system, I don't have this set up. And I think most people running this are not going to have this set up. So it will open up your R environment file. And this is a file where you can basically save environmental variables for R. And I'm going to add this in, save it, restart R, and you'll see basically then it will be added. So this little bit here basically is just making sure it's there. And if not, it's going to make you add it. And then the next part is just adding in your database management system for where your data, your CDM data sit, a connection string to that database, your username for the database, and your password for the database. So these are just the things you always need to add when you try to connect to your database. And then, but underneath that, it's just some code that basically configures a keyring for you that's going to store this information. So you don't have to change anything below that. This is the only things that you have to change. So if I go out of this now, I'm going to open up. Is this the original or the old one? This is the new one. Okay, so this is my one that I already have like things set up. Just going to move the camera over. So I need to go to this keyring setup. If I click this, it's going to now open up in my RStudio, and you're going to see this is exactly the same code that we saw. So I would basically install keyring. I've already installed keyring, so I'm not going to rerun it because actually installation can sometimes take a little bit of time. If it's taken more than 15 minutes for Strategus, sometimes it could just be the installs that we can't really help about. That taking some time. And then this next bit is basically going to check to see. So if I'm going to run this little bit of code, basically it's popped up this R-environ file. And you see, I've actually got one thing here already set for an environmental variable. I have my database jar folder set. That tells me basically the database connector where the drivers are. And you'll see we've got this message here saying, please add Strategus keyring password to your R-environment. So all you have to do is copy this and paste it in here. And now we've got this, we're going to have this environmental variable for the keyring password, and the password is going to be SOS. So if you get asked to put in your password for your keyring, it's going to be SOS that you type. We save this, and now the R environment doesn't actually kick in unless you restart R. So I'm just going to refresh R or restart R. And then this should have restarted, and then I can close this. And what I see is if I run this now, hopefully it won't pop up the renv. Yep, so it skipped the renv because we have this environment set. So if I press this button, or if I copy and paste this into my console, you're going to see it's going to pop out SOS. So I set an environmental variable for Strategus keyring that is SOS. So that's that part set up. And then the next bit you need to do is your database management system. I'm going to use Redshift. If you don't know what to put here for your string, actually, if you type in help database connector create connection details, it's a big help, but right at the bottom, there's going to be a bit that says arguments, and it actually tells you all the database management systems that we support. So here it is. So this arguments here, database management systems, and it tells you here's the strings that you need to use depending on what you're using as your database management system. So that's actually how you can figure out. And these are all the ones we support. So if your database management system isn't in one of these, unfortunately right now it's probably not supported. And then once you've put that in, I've put Redshift. Your next thing you need to do is your connection string. So the connection string, what you're going to do is you're going to say JDBC, and then the colon, and then your database management system. So for me, I'm using Redshift, so I just put Redshift here, then colon, 2 forward slashes, and then the actual server. So I have my server in a keyring because I don't want to share that. It's private, but you would normally put your server here. And you can see from the slides, here's an example that Jenna added for actually like the full thing. But your server is normally just a string with your database at the end. Then you need to put your username in for the database connection and your password for the database connection. Again, I save these as key rings because I don't want this being in the file. I don't want to accidentally share this, so I have this encrypted. But these are basically just, this is just going to be a string that's username. I can spell username. And then you can also have the same for the password. So you're going to be putting these. I do recommend, though, if you're going to be entering this, to use keyring because you have keyring installed anyway. So set the keyring. There's a keyring key set with value. Key set with value. So you can use this basically. You'd put service equals user and password equals whatever your username is, and it would set then a keyring with that. So like I can say here, actually, let me just show you a quick example of it. user, and then password equals made up. If you do this, I can now basically access that made up bit from here. So this is how, if you want to use keyring, that's how you do it. You basically want the value that's sensitive, you want to put as your password. And then you just want to say like the reference for that here. And then you use the key get with the value used here. So I recommend using keyring. It just makes it a lot more friendly. I'm pretty sure like there was a high risk of me sharing usernames and passwords 5 years ago when we weren't using keyring, but it's pretty low now that when I present, I'm not going to show because I'm always going to use keyring. And then the rest under this, you don't need to change. It's basically just configuring a keyring that has the password SOS, and it's going to save these four entries here. And like I said, it saves it encrypted, so you don't have to worry. It's going to be encrypted in your computer for you ready to access when you need to. So if I source this, it's basically, oh, actually, let me not install this first. So I'm going to source this, which is going to run all of this code, and it's basically going to set the keyring. I masked out the settings because I didn't want that to be shown to everyone because I don't want you to see my password and username. But when you run this, you're going to actually see the 4 things that you set pop out, and it's going to be a message telling you that it's set, so you can see it's being confirmed. So that is the first configuration, and that's actually the whole configuration. And then the next step after you've configured is actually going to be to execute. So in a similar process, we're going to see that there's another file, Strategus code to run, and you're going to basically open that up by clicking on it, and then it will open it up in the RStudio, and you're going to see a file that looks like this. And here is basically this first part. So line 2 is telling you to install remotes. If you have remotes installed, you can skip it. Otherwise, you need to install remotes. And then line 3 is going to be using remotes, which is why you needed to install it, to install the GitHub like basically package. And you're going to be using OHDSI/Strategus. So this is going to be installing the Strategus package for the execution. Once you've done that, you can then load Strategus with this library Strategus. And as long as it installed fine, this will load up. The next bit you need to do is basically say a reference for your database. So in this case, we've given the database, the OHDSI database we're going to be applying to, we've given a reference JMDC. And you can basically give any reference. There's a friendly reference. I would say is keep it short for your database that you're basically executing on. And this is going to be used when you are executing. You're going to basically have the results in this output location inside the folder that you named the same value as this. So if I used output location D, Git, Anthony Senna, anti-veg, kidney failure as my output folder, then I would go to the D drive, I'd go to the Git folder, then inside that I'd go to the Anthony Senna folder, then I'd go to the anti-veg folder, and then inside that, there'd be a JMDC folder that would have all the results for all my CSVs. So that's how that gets used. And then the work database schema, this is a schema that you need to have read-write access to, because this is going to be basically the schema that the cohort table gets created in and the cohorts get generated into when you execute. Then you need to have the schema string for your OMOP CDM database. So you need to know what that is. And then, as I mentioned, this output location is the location where you're going to save your results. Min cell count, this is used for censoring values from the CSVs. So if there is a column in the CSV, for example, for some count of patients, if you say a min cell count of 5, if there is a value less than 5, this should get replaced by something like an NA or -5. So this is just to make sure that there's no cell count with a value less than 5 in a column that could be sensitive. And then the cohort table name, this is just any name that you want to give. And how this is used is it will create a cohort table inside this work database schema that has this name. So you do want to make sure that you don't pick a name of a cohort table that already exists, because you may then overwrite some cohorts. So it's good to pick a cohort table name that basically doesn't exist. And chances are you don't have a cohort table called SOS, VEGF, KF. So this is probably a good table name to keep. When I ran this, I kept this table name. And then lines 15 to 20 is setting up the connection details. This is our standard process of using database connector and specifying your connection details. Here, we're using the keyring that was previously created. So in the keyring setup, we created a keyring where we specified and we created a keyring with the database management system, the connection string, the user and the password. Now we're just calling that. So you don't need to change this. If you ran keyring setup, this is already set up for you. So the connection details, which I think is probably one of the thing that's probably the most confusing when you're new to OHDSI and setting things up, is actually already done for you thanks to the code that Senna's written. So this is all we have to do. So I'm going to now jump over to the actual example where I've actually done that. So if I go back to the files, I'm going to go to the Strategus code to run. I'm going to click this open, and you're going to see that I've actually commented this out because I probably executed this at some point, needed this commented out. So here I basically would install remotes. Here I would install Strategus, but I already have them installed and they can take a bit of time. So that's why really the execution should take 5 minutes, but the installing may add the 10 minutes. And then for my database reference, I'm actually going to call that Medicaid 2. This is because I ran this already for Medicaid, but I want to show you what the output looks like. So I'm going to rerun it. So that's why it's going to be 2. And then I've got the work database schema. This, again, I have this saved as a keyring. The CDM database schema, I have this saved as a keyring because I don't want to share this. It's sensitive. I'm going to output to my documents folder. Inside that, there's going to be another folder called anti-VEGF kidney failure. So I'm going to actually show you this in a bit while this is running, because I've already run the Medicaid, so I can go and show you while I'm actually executing this. And I've set the min cell count to 5, and I kept the cohort table the same. So these are basically the only things you have to really input for the execution. 6 inputs, 6 simple inputs, and you're pretty much ready. Here, I'm not going to change this because I used the keyring setup. So this is already set up for me. These values are already put in there. And then below this point is basically going to load the JSON specification because this is in the ins folder. It's then going to store some connection details. It's going to set some execution details based on the values we specified. And then it's going to execute. So you don't have to modify this, but you can see how simple it is to do this execution because everything's really specified in this JSON specification and Strategus knows what to do with it. So if I execute this, it should, well, I'm going to actually point something out. So the one thing that's nice with Strategus is that if you activate your environment and you get all your RMs activated, if you basically you could rerun another study if the environments, the modules are the same. You can rerun a study reusing the activated modules you already have. So generally when you run Strategus, the first thing it's going to do is basically download the modules from GitHub, and then it's going to activate the RMs that are in each module, and it's going to download all the packages that you need, that we know basically are needed for the analysis. But you only have to do that once if you're using the same set of modules. So you can basically, if you run it once, which I did for Medicaid, I ran it once, I've actually got the environment all set up. When I run it a second time, it's basically going to use the setup that I already downloaded. So it's going to skip that part. So it's basically, if you're running all the different SOS studies, you're only actually going to have to do the environment setup once, and then you could actually reuse that environment each time to save you a little bit of execution time. So here, when I source this, it's actually, first thing, I'm using a Mac, so it's asking for the password, which was SOS. So I'm adding in that SOS password we added, and it's going to, oh, did I change the password? Yeah, I changed the password, didn't I? Okay, let me,
It's now made up.
yeah. Okay. Okay, well, you can see my password actually isn't private, so I can actually just change that to, you can see it's just I don't think I care about sharing that. I put it there just because apparently that overrides the basic, when you've given it a name, apparently if you write a user, it will overwrite it. So my username is just JRose. But let me source this again, because I had to fix the issue of me changing the password. So now if I source this, you're going to see that it doesn't ask for my password again, actually, because I already did that, but it will ask me a few times for that SOS. So I put SOS a few times, and it's basically reusing the modules and the environment that I had previously. So now it's skipped straight to basically trying to do cohort generator. And it actually has already existed, apparently, because I ran it previously. But it hasn't redone the cohort. So it's redoing the cohort generation. So right now it's just generating the cohorts. And what's going to happen is once it's generated the cohorts, that's cohort generator module completed, because this is the cohort generator. And then it will go on to the next module, and then the next module and the next module. Because I'm using a Mac, it asks for the password. It's going to ask for that SOS password every time a module starts. There is a way of opening your keyring so you don't have that. I've been too lazy to figure that out. But I do know Senna and a few other people have the solution for that. So if you don't want to enter your password repeatedly, if you're on a Mac, there is we can basically show you how to do that. Although I've been too lazy to figure it out. If you're using a Windows, it's not going to ask you a password. It's very unlikely. I don't get asked the password when I run this on Windows. But while this is running, just to show you, I just want to show you how it actually executes and how simple it is. I'm actually going to show you the results I generated for the Medicaid 1. So I didn't know I was going to do Medicaid 2 at the time, so I didn't call it Medicaid 1, I just called it Medicaid. But effectively, this is the output that you get. So when you run a Strategist, you get a Strategist output, and this is the main thing. This is the thing that has the CSV files. So I'm going to show you that in a bit. You also get a Strategist work. Strategist work is just while you're running each module, sometimes it has to like download data and run certain aspects. So this is kind of like what it needed to actually do the work. So that gets saved here, but you generally don't need to investigate that. That's just something that's kind of there if something happens and you wanted to look at the source data that gets downloaded for prediction or cohort method, you could look at it there. And then execution, this is just the script that actually gets created. So Senna, when he creates Strategist, he actually creates something called a target script. And targets is this way of like doing management of like a process of a pipeline. And that's all in this execution. So again, you don't generally have to look at these two. Okay, so cohort generator is done. It's basically now doing cohort incidents. So you can see here, it's now cohort generator is completed, CSVs are done. So if I go to here, if I go to output, you're going to see in cohort generator, there's already a bunch of CSVs. Cohort incidents already ran. You can see how quickly that is. So now if we go to cohort incidents, we're going to see CSVs here, and we could open these up to actually view the results. So as Strategist goes along, it calls a module, it runs a module based on your JSON settings, and it spits out those CSVs. And you're seeing right now in the run that I'm currently running, it's running cohort method. But if I go back to the original one, I've actually got everything. So I've got the cohort generator, cohort incidents, cohort method, self-control case series, characterization, patient health prediction, and cohort diagnostics. And if we open these up, you're going to see a bunch of CSVs. So what we recommend is that you view those CSVs just to make sure. So if you have self-control case series, for example, we can go to the results. You can open up that CSV and see what's in there. So you're getting effect estimates here. It can be a little bit hard with CSVs to understand what these really correspond to. So you've got analysis ID, you've got some exposure outcome set ID, covariate ID. It isn't really clear what this RR is really for. So the CSV is good just to make sure that there's nothing here that worries you. So there should be no values less than 5. And you see this basically is -5. So what's happened is there was a value less than 5 here, so it got replaced by -5. And this is just telling us that there is a value less than 5. But we don't know what the value is. So you want to just check things like that to make sure that there's no small values and that the min cell count worked. And you just want to make sure that there's nothing here that you don't want to share in terms of the columns. And then if you're happy, basically you can share that back with the coordinator. I'm going to also show you quickly how to generate the Shiny app that will let you explore, and then you can actually see what these actually correspond to. But that's actually going to be more next year. Next week, we're going to explore the results, but I can at least show you how to generate it. So if you've got to this point and you want to really see what your results look like, you can. So I'm just going to stop this because you can see it's kind of, you can see how it executes. It's just going to basically continue and just go through one by one each module, spit out the CSVs. But once you've got your CSVs and you're happy, the next thing you'd want to do, so I'm going to go back to the PowerPoint just so you can see where we're up to. So I already basically did I showed you the review. Basically, it's just going through and looking through the CSVs. So the last part really is the sharing. So the sharing, again, Anthony created this super simple script. It's called share results. You open it up and there's just like 4 different inputs you need to basically specify. And this will let you share these results back with the coordinator. So go back to my R, which I believe is this one. And if I go to share results, opens up share results. I've got Medicaid here because that was the reference I've used throughout. I've got the same output location that I've specified in the Strategus code to run. So this is where my results live. And then here you're going to have to get the key ring, the key file name and the username. This needs to basically be given to you by the coordinator. So we don't want to give this out openly to everyone. We just want to make sure this is only given to people who have the data and the results they want to share. And this is basically, so you just need to email the coordinator to get these values and you would just put them in here. There's basically just going to be the location you share and then some username. So like you would put in like your some information about the study and your data site. So these you just need to ask for. So you don't even have to think about that yourself. Just ask for it and then put in whatever values are given. The only thing you have to do is just make sure you put in the same reference and the same output location as you put into Strategus code to run. Then that's all you need to do. But below this line, it's just going to have functions that zip the output. So it's going to go into this. It's going to extract this folder, which is just the modules with the CSVs. It's going to zip it, and then it's going to do a SFTP transfer of that zipped folder with the CSVs to the coordinator. So the code here is just basically doing that. Below the line, it's just zipping and sending. So if you have this, you would then just fill in these values, press source, your results are now shared. Shouldn't take too long. So again, a very simple process. But before we finish, I want to show you how to actually use strategy. Well, how you can use the Shiny app to view your results, because you probably are quite curious once you generate your results. You probably want to see what it looks like. So there's this file here, which again, Senna created, which is super friendly. You basically add 2 things here. So you put in your connection details reference, which is Medicaid. You put in your output location, which is the same location you specified in Strategus code to run. So you just want to, the only thing you have to do is make sure these 2 values are exactly what you put in for this and for this. And if you make sure they're consistent, then you can run this code. And what this is going to do, so the code below here, it's quite a bit going on, but effectively it's creating a local SQLite database. And then it's adding those CSVs into that database, into a bunch of tables that we've designed for holding all our results for the different modules. And then that's it. Basically, you have a local SQLite database with your results. And I've already run this. And if I run it again, it actually I can run it again because I've moved it, but you can see it takes a bit of time. So this bit does take a little bit of time to insert. So if I run this, what you're going to see is it's basically creating the tables and inserting all the results into some tables. And it's probably going to take quite some time. So I'm going to stop this because I already have, it lets me stop it. I already have the results basically in an SQLite in a slightly different location. So I ran this code and then I moved it to a Medicaid app location. So I have my results there just so I can show you. But basically you would normally just let this run till it finishes. And then once it's uploaded everything, you would flip over to this app.r. And this app.r, all you have to do is make sure you have Shiny App Builder installed. make sure you have OHDSI Shiny modules installed. And you also need to make sure you have Results Model Manager installed. So I'm actually just going to add, to realize that isn't in there. But you do need Result Model Manager. So these are the 3 things that you need to basically ensure that you have installed. And once you've got those 3 things installed, you can then basically make sure your reference is the same as before. So Medicaid, make sure your output location is the same as before. So documents, anti-veg, kidney failure. And if I run this, it's basically going to use the database we created for this upload, this SQLite database, and it should basically show me a Shiny app that basically tells you results for all of the modules. So I'm not going to go into detail of this because this is going to be explored next week, where we actually go through the results for all the different databases. But effectively, you have a Shiny app now that has a cohort section that will tell you what cohorts are generated. You have a cohort diagnostics that has the general cohort diagnostics app that people are used to. So it has all of these cohort diagnostics reports that you've seen in previous weeks, has a characterization module for displaying the characterization results, has a estimation module for the cohort method, has a self-controlled case series module for self-controlled case series results. So as I was saying, when I explored those results, it was hard to actually interpret what the relative risks were corresponding to. But if you go to this view, you can actually go to the result and you could actually see for an exposure and an outcome for your analysis in a database what the values would be. And it also has a prediction view, which hasn't been populated yet. But basically, this now is one Shiny app for all results. And again, this is different. Before, we used to have Shiny apps for prediction and Shiny apps for cohort diagnostics, and they were separate. Now, because we've gone to this whole modular approach, we're able to create one Shiny app that has everything that you've generated. And as I said, this will be explored more. So last, before I give you back to Craig, I just want to highlight that we do have an app active right now. So we have this data.odyssey.org/anti-VEGF kidney failure Shiny app. All the results, as they get shared with the coordinator is then going to upload these into this Shiny app. So over the next week, you should start to see results being added to this Shiny app. Right now, there's just one result in there, but this will be expanding. So if you're interested and you want to keep checking out the results, you can go to that app. It's a Shiny app like I just showed, but it's going to be the central Shiny app that has all the results for all the different data partners. And at that, I will hand you back to Craig.